Dear students, um, these videos which may going to covers that is the our syllabus. Already we are seeing this topic up to operating principle, over current relay, torque equation, RX diagram, and electromagnetic relay operation. Now we are going to see this the over current relay, that is that over current relay, and if it is possible, that is the directional over current relay also, right? So in this over current relay, so this is that the current. So yes, so this is that the over current relay. So basically we are going to see the construction of that over current relay. The over current relay for the induction type. This is the induction type over current relay. Already we have studied the basic concept in this operation of the induction moving system in the measurement instrumentation section. At the same time, how we are going to see this the basic operation of that the this element. So normally this is that the upper element. So this is upper, okay, upper element. This is that the lower element, okay. So how this element will be working at the base of induction principle, right? Now we are going to see the basic operation of the this relay, right? So again, uh, we are going to take into account for this relay for in the whiteboard, or if we are going to see that is the different types of relay. Normally that is the induction relay, that is induction, okay. uh, we are going to take on this, sorry, okay, induction type, induction type relay, okay. Induction type relay, this is induction type relay. Normally we have that is the these type of, that is the two magnetic poles as like this, because these poles we are going to assume as like this, okay. So again this is that the type we are going to see here, that is the operation if it is necessary. So we are going to provide the basic operations of that the relay operations. So this is that the two pole. Again, if we are going to see, that is the operation due to the induction current, due to induction, that is the eddy current, okay. Due to eddy current, that is the two circular forces which may be going to create that according to that EM of operation. So again this force which may be going to connected as that in the two forces, basically this force in this direction and this force in this direction. Again we are going to connected this force. So basically right, again the rotational directions which may be created, okay. So normally the electromagnetic which may be created, this is the aluminum disc, this is the aluminum disc. So one electromagnetic force, that is electromagnetic law of induction, another one force due to presence of this eddy current, that is the one rotational action is produced here, again another one rotational action. So this is the round electromagnetic force, again that is that the rotational action is produced in the system, right? So this is the basic operation. So this is the upper electromagnet, this is that lower electromagnet. The upper electromagnet which having, that is the current here, this is over current relay, over current, okay, over current relay. This is over current relay. The actuating quantity is the current. Which one is, that is the current, okay. So that is the I is the operating quantity. so or actuating quantity, this current is obtained from the CT, current transformer. CT, which means that is the current transformer, again feeder into that the system. Here we are going to use the, this is act as a PSM, plug setting multiplier. So based on that plug setting multiplying action, again that is the connection, it will be wounded in the upper element. Again this upper element which may be going to connected through this lower element, so the electromagnet is created. So this is the basic construction. Again that is the a small spindle is there. This is the aluminum disc. Again it may be a small needle which may be connected here through this the 2 points. Okay, this is the basic construction. So basic construction, one upper electromagnet, lower electromagnet. So the winding is wounded, the input of that winding is derived from the PSM, plug setting multiplier. This input is get from the CT. The another end we are getting from that another end of the CT. This element, lower element is connected in that the series with the this system. So this is that another one concept. Again the rotational operation is produced based on that this analysis. This analysis we are going to get the operation in constructional feature. Please see in earlier video we are discussed about the time setting multiplier operation, time setting multiplier TSM, or time multiplex setter. Some bits as different in some way, that is different way. So this is the relay, this is the relay contacts. So this is, these are all the relay contacts. So we are going to see. So this is the aluminum disc, that is AL disc. Okay, aluminum disc. So again the, this is the plug setting multiplier. This is the PSM, plug setting multiplier, that is the current rating or setting. The secondary of the CT is connected here. Again the relay contactor NO and NC is connected. So this is the overall construction of the overcurrent relay. Okay, so whenever the fault current, next we are going to see the operation of the relay. Whenever the fault current, that is I is greater than that is the rated or rated value. Suppose the rated value is 25 amps, so I is greater than the 25 amps. So the flux, this is the point. According to that plug setting multiplier, the electromagnet become a electromagnet. The lower again the winding is wounded here. This is the lower magnet will all act as electromagnet. Again it may be going to rotate and then connect this contact. So before the 25 amps, the operating quantity, that is the flux produced in the disk, is not sufficient to rotate. At the after 25 amps, above the 25 amps, the flux produced in the magnetical flux, because higher current, it may be rotate and then connect the or activating the relay. So this is the basic operation of the overcurrent relay. Okay, this is the basic operation of the overcurrent relay. So this is at the same time is a non-directional relay. Okay, so non-directional means, suppose this is that node A, again that is the node B, we are going to put as a CT and then relay is connected. If the current is A to B, or is current to is B to A, if the magnitude is exceeds, is greater than the 25 amps, then the tripping circuit, that is the tripping circuit is enabled. Okay, so this is the basic concept of overcurrent relay, right? The another one part of the relay is, that is reverse power or directional relay. So reverse power, this is the reverse power or that is directional relay. So before entering to that the point, we are going to consider here. Please see that the main thing. Suppose we are assume this is that the assume this is that the voltage. So this is V, that is voltage, and also we are assumed as that is that the current in suppose it may be see as like this in the unity power factor, in the unity power factor. So this is that the I, both and I. So please see and wait. Uh, Both V and I has the same quadrant. Okay, same quadrant. It may be lagging and leaking. So this is act as a loading effect, or that is it may be generated at the same time. If it is that is the generating unit, if it is that is the generating unit, please see that is the concept. So this is that the voltage, and this is the again the voltage. So this is for that the current. Okay, please see that is here, um, here that is voltage V and I. So V and I are in the same angle, but here this is the V midpoint, this is that IA. So that is the 180-degree operations we are going to take into account, right? So that is the process we are going to taken into account. Suppose I am going to taken as that the calculator. So this is that the yes. So this is the that is the scientific calculator. So which is we are going to see that is the operations. So what I am say, sine and cos and everything we have going to take into account. So what is that the trigonometric function? Here we are going to take as a sine of what is the value, that is that the 180, right? So sine of 180. So sine of 180, then we have going to what is that the effect. Okay, sine of 180. So this is the sine of 180 is the function. Again sine of 180, what is that the 0. So again that is that the trigonometrical function sine, that is the cos. We have going to cos of again 180 is equal to 0, which means 90 is equal to 1. So suppose we have going to be assumed that is that sine of wait, so that is the function. So that is calculator. So this is that the calculator in the trigonometric function sine of which means 90 means, and then 100, and then we have going to taken. So this is sine. So 100, that is the 0.8, it is in the plus. Okay, suppose if it is in that is what is 200, I am also going to put the 200 and then put the sign which may go into in minus. See, minus. So similarly, that is the option. This is the wave is a sine wave. Sine wave. Okay, this is the wave in the sine wave. That is 0 to 180 degree. 0 to 180 degree. From 0, this is the pi value. This is the 2 pi. So 0 to pi, that is that 180 degree. So sine of that is the 180 level, which may be in the positive region, which may be in the positive. So again that is the 180 to again 360, that is we have going to is in the negative. So that is the power flow here, that is we are in the negative. So we need, so find the direction, find the direction. Please write direction. So find the direction, we need the voltage and current. Okay, So voltage and current, both the things we need for find the direction. Okay, if the voltage that is as per this quadrant of that operation, if it is lie in this direction, so which may be, this is that, suppose this is voltage, that is if it is the current in this area, in this area, so this is that the positive, that is positive here, the positive, that is theta theta, one direction, that is which may be going to, this is lagging in L, this is C capacitance as a leading. At the same time, this is the V, the current is in direction or in this direction. Okay, so in this direction, so this is the same thing, we are going to take as that the this is L and C, but if this is in the that is supply, so this is in the observing. So based on this concept, the directional power and the directional relay which may be going to working. So the direction relay able to detect whether the point of the fault lies in the forward direction and reverse direction. So if this is the point here, that is the CT which is available. Suppose the fault is created, the fault current is flow in this direction. Suppose that the fault is on another direction. Suppose the fault is created, again the current which may be going to in this direction. Okay, so both the directions will be changes. For this purpose, we are introducing the directional over current to sense the direction of the power and sense the direction of the fault current. So we are going to see that is the basic constructional operation. So already what is the element which is we are seeing in earlier, that is the non-directional. Okay, non-directional over current relay, the same thing what we are seeing, the operation is, this operation is the same here. At the same time, that is the CT, supply from the CT is seriously connected from the element, so seriously connected to the directional element. Similarly, the another point of that the CT, another point of the CT which is wounded here, right, is wound and then connected in the lower element, the lower element which is connected to this closing point. Okay, suppose the direction element, so V and I. Okay, V and I. So this is one is V and another one I. V and I are in the same direction, it is not functioning, it's not functioning. At the same time, V and I in the opposite direction. So this is that is 0 to 180 degree. So this is 181, which means 181, 180 degree is to that is 360 degree. This element will be actuated. This directional element is actuated. The operating principle already explained based on that this criteria and this, and a calculator I am also going to explain how that is the sign of the wave will be actuated. So this is the basic operation of that the relay which may going to working in the directional and non-directional operations. Okay, this is nothing but the power relay. This the lower element will be energized from the CT current. So the upper limit is the voltage. So V and I which can be calculated. So this is the voltage. Again this is that the current. The algebraic sum of that is the theta. The afflection angle is theta we are using. So one of the quantity is the operating quantity. Another one is the restraining quantity. Right. So here both the systems which may be going to wound up. Please see. So this is that the winding. So this is a shading ring we have for adjusting the correcting. So correcting the phase, that is phase angle, that is the correct the phase angle. Shading ring we are utilizing the operations. This is actually nothing but that the closing tripping relay. This is the basic construction of the reverse power relay. So suppose if it is the I2 here, please see, this is that the V voltage is applied to that the system, again 90-degree lagging by the element I2. This is that the element is 90-degree lagging. Again I or I1, this is the I1 element. What is we are here, we are going to do it. So if the element is lagging or leading, 5 and theta is there. So that is torque is equal to, already we are seeing the torque equation, I1 and I2 sine 90 minus 5. So or proportionally, that is I1 I2 cos phi is directly proportional to Vi and into cos phi. So this is nothing but that the operation of the power relay. So if it is this angle is changes as per this operation, this angle is changes. What I am saying. Please see, right? So as per that is the principle, this angle is changes, again that is the point of operations will also going to change. Okay, right. uh, we are going to back. So based on that principle, the system which may be going to work in the power, one is the operating quantity voltage and the current. So the phase angle obtained by these operations, so the phase angle is changes, again the power is reversal, the relay will also going to make a trip the system, right? So next, this is the basic thing. Already we are seen how that is the two force, the phi 1 and phi 2 actuating. I am also explaining in this operation here. Here I am already explaining these operations. So this is that the reverse and the forward direction how we are going to find. Please see that is the operations. So this is that the sine wave. So the reverse, which may be, this is the 180 degree, right? 0 to, that is the 180 degree of operation. This is that because sine wave as like this. So this is that operation. Again that this is within the 180 degree. So this is the forward direction. This is in the reverse direction. The relay, if it is in the forward direction, it may go into not tripping. If it may be going in the reverse direction, it may go into trip. So what is the use of that the relay? Now we are going to see with the help of this diagram. First of all, we are seeing that the power flow. So suppose this during this fault, so this fault which may be going to flow of that the current as like this, it is possible to go. This is the one path which is easy to flow. At the same time, the fault current here, we are, it may be going to flow on these directions. So this is earth under these directions. Okay, so please see this diagram. Diagram as per, this is source, this is load. The current flow is from the source to load. Okay, so if it is any fault is occur, during that time the current reversal is occur. So the relay number 67 is the number relay of that is directional or that is reverse over current relay. Okay, so this is that the point, reverse power relay. Again we have going to be considered. Suppose the fault may be occur here. Suppose that is the fault may be occur here. Again the 6-7 relay is operating to isolate this system. By using this relay, one line is healthy line which may be going to earthing, the faulty line which may be going to isolator. This faulty line which may be going to isolator. So this operation, it is useful for the distribution system. It is used for which system? That is distribution distribution systems. Okay, suppose if the fault is occur the place of here, the fault is occur here, that is the fault is occur, what is the effect is created. Now we are going to that is introduce that is the here one CT which may be connected in another one CT, and then connector to produce the differential protection. Okay, so differential protection, this differential protection which may be going to be used for to protect this bus bar. So we this operation we are seeing later. Okay, so this is the purpose of that directional relay which may be going to protect our the bus bar. So up to this, so this is that the basic operation. Already we are seeing the directional relay. Okay, so this is that the relay characteristics at all we will see that is the operation in the distance relay concept. Okay, up to this the different types of relays we are seen in induction cup type relay. So this is the induction cup relay, that is the 4 pole is available. So one is that the current which may be in another one is the voltage, so it may be act as a power based relay. Again that is the this is that the voltage coil, again that is the current coil. So connection of that current coil for the reverse power relay. So suppose if it is the normal relay, it may be directly connected. Okay, if it is reverse and then reverse, both flux, which means psi of v and psi of I, both are that is in the opposite directions. So if it is the fault current is increases, the psi of I which is greater than that psi of v, that is the tripping system will be automatically working. So this is that minus of I, please see that is the minus of I. Suppose I am also going to put that the direct this is that the 180 degree of sine. So this is that is greater than that this quadrant, again it may be going to act as that reverse directional relay. Okay, so up to this video which may going to cover is the topic. So cover the topic of overcurrent relay and the directional overcurrent relay. So this part we are covered. Okay, right.